This video discusses confidence intervals for the mean, covered in Chapter 8. We start with an example. We sample n equal to 162 social science majors and obtain a sample mean of 102 on an IQ test. X bar is 102. We know that for these types of IQ tests, the standard deviation is sigma equal to 15. We want to generalize our results from the sample of 162 students to make a statement about the mean of the population of social science students from which we sampled. We want to make a statement about the population mean mu. A point estimator for the population mean is the sample mean x bar. So our estimate of the population mean is 102. But if we take a different sample, we may get a different value. We can show that the standard deviation of the sample mean is standard deviation of x bar is sigma divided by the square root of n. For our example, it is 15 divided by the square root of 162, or 1.179. We know that from our standard normal, or z table, that the probability of minus 1.96 less than z less than plus 1.96 is 0.95. So there is a 95% chance that a normal random variable will fall within 1.96 standard deviations of the mean. So if we look at the standardized variable z equal to x bar minus mu divided by sigma over the square root of n, then it will have a standard normal distribution. So we have minus 1.96 is less than z is less than plus 1.96 with 95% probability. Hence, minus 1.96 is less than x bar minus mu all over sigma over root n, which is less than 1.96 95% of the time. So we solve for mu and say we are 95% confident that the population mean mu is between x bar minus 1.96 sigma over the square root of n and x bar plus 1.96 sigma over the square root of n. We write this as x bar plus or minus 1.96 sigma over the square root of n. Substituting our values of n equal to 162, sigma equal to 15, and x bar equal to 102 gives a 95% confidence interval for mu as 102 plus or minus 1.96 times 15 divided by the square root of 162, or 102 plus or minus 2.3, or equivalently 99.7 to 104.3. So we are 95% sure that the mean IQ score of all social science majors is between 99.7 and 104.3. We may wish to have other confidence levels. If we want to be 99% sure, then we use a z-table value with a probability of 0.99 in the middle. So the probability of minus 2.575 less than z less than plus 2.575 is 0.99. So a 99% confidence interval for the mean is x bar plus or minus 2.575 sigma divided by the square root of n. If we look at the normal curve, we see the 95% and 99% areas illustrated. We now give a general formula for a confidence interval. We take the sample mean plus or minus the z-table value times the standard error of the mean. We now look at the case where the standard deviation is unknown. If we do not know the standard deviation sigma, then we estimate it with the sample standard deviation s. However, we are introducing more variability by replacing a known value with an estimate. Instead of using the z-table, we use a t-table. So we use the student's t-distribution. The t-distribution depends on something called the degrees of freedom. In this case, we have n observations and estimate the one population mean mu. That leaves n-1 degrees of freedom to estimate sigma. For a 95% confidence interval from U, when the population standard deviation is unknown, we use a t-table critical value with 95% probability in the middle. That leaves 5% between the two tails, or 2.5% in each tail of the distribution. We sometimes say 2.5% or 0.025. We compare the t on 2 degrees of freedom with the normal curve. It has fatter tails. We see that as the degrees of freedom become large, the t distribution looks like the normal curve. We read the t-table by looking for the column with 0.025 in the tails and reading down the degrees of freedom column and finding the value. For example, for 4 degrees of freedom and 0.025, we see the value 3.495. Here are the 5 steps for a confidence interval. 1. Calculate the sample mean. 2. Determine the confidence level and the critical value from the table. 3. Calculate the standard error of the mean. 4. Calculate the confidence interval. And 5. State conclusions and interpret the interval. Let us consider another example. Consider a small sample of n equal to 5. 1, 4, 6, 8, and 9. The sample mean is x bar equal to 5.6, and the sample standard deviation is s equal to 3.21. The degrees of freedom are n-1 or 5 minus 1, which is 4. The table value with 0.025 in each tail on 4 degrees of freedom is 3.495. So 1, x bar is 5.6. 2, choose 95% as the confidence level with a table value of 3.495. 3, the standard error is s divided by the square root of n, or 3.21 divided by the square root of 5, so the standard error is 1.44. 4, the confidence interval becomes x bar plus or minus t subscript 0.025 times s over the square root of n, or 5.6 plus or minus 3.495 times 3.21 divided by the square root of 5, or 5.6 plus or minus 3.495 times 1.44. That gives us 5.6 plus or minus 5.0. Equivalently, 0.6 to 10.6. Note that this is a wide interval, as we only have 5 observations and the standard deviation is unknown. 5. Interpretation. We are 95% sure that the population mean lies between 0.6 and 10.6. Thank you for watching. In the next video tutorial, we cover the t-test for a single mean.